The last type of asymptote is the slant asymptote. Y equals mx plus b, which is the equation of a linear function, is a slant asymptote of f of x if f of x approaches that exact line, y equals mx plus b, as x approaches infinity or x approaches negative infinity. Here's a scenario to help you picture what it looks like. Let's say this is a slant asymptote. The graph has this behavior where it's approaching the line as x approaches positive infinity. At the same time, it could be approaching the line from this side where x approaches negative infinity. Given f of x is equal to p of x over q of x, a slant asymptote only exists if the degree of the numerator is greater than the degree of the denominator by exactly 1. And to find an equation of a slant asymptote, we want to divide the polynomials. The quotient you found would be the slant asymptote. Let's look at this example. Find the slant asymptote for f of x is equal to x squared plus 1 over x minus 1. First, you need to see if a slant asymptote may exist by looking at the degrees. The degree of the numerator is 2 and the degree of the denominator is 1. Because 2 is greater than 1 by exactly 1 unit, the slant asymptote should exist. To find it, we are going to divide these polynomials here, and you can either use long division or synthetic division here. I am going to use long division. So first we set up the dividend, which is the numerator, x squared. Looks like the x term is missing, so I'm going to insert the term 0x and then bring down the plus 1. And then for the divisor, we have x minus 1. So we are going to do the divide, multiply, and subtract method over and over. So divide x squared, divide by x, that will give us x here. Multiply, x times x is x squared, x times negative 1 is negative x. Then subtract. These two terms will cancel. You could think of this as negative 1. So 0 minus a negative 1, that will give us 1x. And then bring down the plus 1. Divide again. 1x divided by x will give us positive 1. Multiply. 1 times x is 1x, and 1 times negative 1 is negative 1. Now you subtract. These two will cancel. 1 minus a negative 1 will give us 2. So after dividing, the quotient that you found here, which is x plus 1, will be the slant asymptote. So y equals x plus 1 is the slant asymptote for this function.